But 5G standalone architecture is the architecture that actually addresses the business verticals, that talks about the enterprise digitizations, that talk about the revenue, or we can call it the business model that brings the revenue from the business verticals. But the real monetization of the 5G comes in when there is industrial verticals jumped in and they ask CSPs to give them a solution to manage their latency requirements. For example, factory automation. How we can get rid of a traditional manufacturing process in industrial automation by using the robots and artificial intelligence, big data. That's what the 5G comes in and gives you the solution.
Service assurance is becoming actually essentially a network function, and we'll look at what needs to evolve for that to be true. But there's a lot of complexities that mean that the existing systems we have today are going to be severely challenged in this highly disaggregated architect. Virtual networks is really like managing a completely different network. So they're managing 2 networks. With cloud native, we're going to be managing 3. One of the big problems we also have is it's very difficult, even today, to really resolve the experience of individuals. Why is that important for 5G standalone? Really seeing the individual is critical because we will have SLAs in these ultra-reliable, low-latency communications that go down to the individual human or machine. In addition to those kind of challenges, we also have the absolute volume of traffic. So looking at a tier 1 operator in the US that we're working with, 40 petabytes an hour to analyze and do the analytics on. If you use traditional systems today, they just wouldn't scale to be able to digest that amount of traffic, and on top of that, the cloud bill would actually be monstrous. And that's something we learned during virtualization, is that often the bills related to virtualized infrastructure, if they're not optimized to elastically scale using microservices, can actually exceed the cost of the systems that were actually purchased to run on the virtualized infrastructure. And this is an extremely dangerous trend that we need to control as we move into a very large-scale data networks with 5G standalone. So the net conclusion of this, just looking at the challenges there are ahead, is that the telco transformation is happening now to 5G standalone. We need to see the individual very clearly. We have to understand that and produce SLAs that can make the end consumers and industry confident in the telco services. But at the same time, if we don't change the way we're looking at the network and integrating with the orchestrator, we're actually losing visibility when we need it the most. The ability to see all this in action is really required for the orchestration plane to make its decisions in real time across these different architectures. One thing we've learned, as we saw before, is that the ability to analyze all this data at the same time, seeing it all in real time, is difficult. So one thing that's been a trend now is to move towards an AI-driven real-time streaming analytics to overcome these big data delays, allowing us to see the data that really matters in the moment, in the context of what the orchestrator needs to do and what the automation is trying to achieve from an intent or policy base. And in this case, there's this concept emerging now of adaptive service assurance, something that actually doesn't measure everything and analyze it all the time, but really listens to the orchestrator and allows it to collapse the time and the cost of collecting the data that's required. So you can actually predict and prevent impacting events before they happen, but also prescribe the root cause when they do, so the orchestrator can continue in a closed loop fashion. Just to take a look and zoom in on the distributed kind of aspect of this, we know that the adaptive data collection now is becoming an essential element. So in terms of fast loop control, monitoring, and analytics, when you collect things locally and process them and only store what matters, you end up with just the right kind of data you need. You only retain and process what you actually need to what you're looking for. And also you can really store only things that are necessary, but keep them local for when you need to consult them later.